Thank. All right, think we're good to go. I'll start sharing my screen. All right, let's get started. So hi, I'm Shruti Sriram. I'm a PM on the ODA team, and I'm here with the On the Air with ODA series. And today we'll be talking about the whole process of deploying and go through a demo for application KVMs. So, a bit about what we're going to talk about today is we'll start off talking about virtualization support, the process of creating and deploying app KVM on ODA, and then how you can access this app KVM once you've created it on the ODA. And at the very end, we have a recorded demo. And then this actually shows the Sandbox application and how it was set up, and then just the process of the full life cycle of the app KVM as well. So at the end of that, we'll have a Q&A, but please feel free to add any questions that you have in the chat, and the other PMs are in the speaker as well. So they'll answer some of the questions and we'll get to them at the end. All right, let's get started. So our first section we'll talk about is the virtual support with the KVM. And I guess the biggest question is, what are the benefits of virtualization? So we have four main categories that we have over here. And the first one is savings. By virtualizing, you have significant savings and you reduce the number of physical servers and storage devices that you need. It also lowers the space requirement and the power consumption, making it overall very cost effective. It also allows for improved security. So each of these virtual machines and applications are isolated. So this really provides additional security and minimizes the risk of cross-application issues. It also provides a higher quality of service. It's very easy to manage your VM, and it can create consistent performance at the VM level and maintain this quality across workloads. And also, it provides higher efficiency through server consolidation. There's better resource management, and the way that resources are used are better. So this integrated solution in a box, so that has the application, the middleware, and the database, all like streamlines deployment and operations, and together all of these factors help drive much more efficiency. So let's talk a little bit about what the virtualization support looks like. So the KVM turns the Linux kernel into a hypervisor, which gives industry standard platforms for both cloud and on-prem. And it has a strong isolation of CPU, memory, and OS so that customers can safely consolidate production, dev test, and departmental workloads. There's also hard partitioning and CPU pools, which allow licensing databases by VMs and keeping the workloads separately. Through integrated management of the ODS stack, it's very simple to create and modify and delete, basically manage the complete VM lifecycle just through the GUI or through the command line. It's very simple to do all of these things. And there's with shared storage and VLAN, there's many features for customers to access. And there are really two big types of KVMs, which are the app KVMs and the database KVMs. And with the app KVMs, customers can manage applications inside, like Sandbox that we're seeing today, or any other apps within the app KVM. And then the other option is the database KVM, which optimizes the overall deployment of a database In this case, it's the 23AI database. So those are the two types of KVMs that users can create when they virtualize. So this is a little bit of an overview of the virtualization architecture. And you can see over here in this diagram, we have a HA system with node 0 and node 1. And in this diagram, we can see it's using a type 2 hypervisor right on top of the host OS. And this design is uh, aligning perfectly with OCI, which is the Oracle Cloud Infrastructure. So it's been engineered for that design as well. And then you can see that the two nodes here, node 0 and node 1, have an application KVM and the database KVM inside. And then each of them has the host OS, which includes the GI, the grid infrastructure, as well as the appliance manager. And this is, you can also see here that there are shared storage and then as well as the total licenses that are used in the databases for both of these nodes. And oh, one more thing to mention is the license flexibility. With you only pay as you for what licenses you use. So the total number of cores used in the database KVM would be going toward that count. And now to speak further about the high availability architecture with these two nodes. We have node 0 and then node 1 here, and we have a diagram where we're showing the KVM failover. So you can see here that when the app in node 0 fails, it's failed over to node 1. And in this diagram, we can see that it automatically restarts up on the KVM in the other node without any manual intervention. So this is one of the features of the HA system where the KVM failover is fully automated. And as we can see in this picture, this is an HA system that's fully integrated with RAC. And the application VM is a high availability resource that has the clusterware running on the host OS system. So in case of any outages, in this case, it would detect the failure and with the shared storage between both nodes, it's just able to automatically restart the application KVM on the second node. So this just gives seamless protection for your entire application stack. So in the next section, we will get into the process of creating and deploying the ODA app KVM. So this is a bit of an overview of the life cycle of creating an app KVM. So we have step 1 here, which is you can create a CPU pool. This is a dedicated set of CPU cores for the application tier, and it ensures that the application has guaranteed access to processing power without interference from other workloads. And then in the next step, you can create the VM storage and the vDisks. So and through this, we can allocate VM storage and we can allocate the vDisks that are necessary, and we can ensure that the VM has enough space for the operational system and application data. And in the next step, after this, we can create the KVM with ISO image. In this example, in the demo, we've used the Linux OS 8 image. So whatever image you want to install, you can go ahead and install that on the app KVM. And then once this is done, you can modify the app KVM as you need and then delete it to end the life cycle if you're no longer using it, or you can start and stop the KVM as well. So this is just an example of the UI. So this is the overall browser user interface for ODA when you're creating an app KVM instance. So you can see over here you would navigate to the Appliance tab and then Compute Instance. And then you would see VM instance over here. So you can go to the type in these details, which we'll go through in the demo, and then use this once you've created the VM storage and created the virtual disk and virtual network. You can create a VM instance. So if you prefer to use CLI for more granular control, that is an option as well for people who prefer to do that over using the browser interface. So you can use the same steps to create a new CPU pool or create a new VM storage. So all of these steps can be done through the CLI as well. So next we're going to be talking about how you can access the actual ODA application on KVM. So there's a couple of options. You can use the CLI, the command line, and SSH in. Um, and then for Tiger VNC viewer, you can just go there and access the node as well. Or else you can use Linux Cockpit, which we will show to manage the life cycle of the app KVM. So there's a couple of ways to connect to the app KVM. So now we're going to get into the step-by-step demo portion. So I'm going to start sharing the demo. All right, so for this first part of the demo, we will be seeing how the initial VM storage, virtual disks, and virtual network are created, which are all required before you create a VM instance. So the first step is creating a VM storage where you can enter the VM storage name, select the disk group and size, and go ahead and create the VM storage. And then once you create these, you can manage all of these jobs in the monitoring tab. So you can head over to the monitoring tab and see if the job was successful. We've done the same with virtual disk and now with virtual network, where we are entering the name, the IP addresses. In this case, the interface is BT bond, entering the mask, and then we've created the virtual network. So that was just the overview of the first two steps of creating the VM storage vdisk and creating a virtual network. In this case, we did not create the CPU pool. That is an optional step for users to do. So we've just created these two, which are required to create the KVM instance. So once you've done that, the next step is getting the ISO image. So there's a couple of options. You can have an endpoint, you can download the ISO image, whichever of these to start to have this for your KVM. So in this case, downloading the Linux OS 8 image. So this is the process of how we're doing that. So I'm just going to Google and typing the Oracle Linux 8 image. I navigate to the first page, and then I'm over here, and then going to the Oracle Software Delivery Cloud from that. And then I am going to type in Oracle Linux 8. And then if you want to look up another version, you can as well. For the purpose of this demo, I'm using Linux 8. And then I'm just going to go ahead and download all of that as well. So at this point, you would download whichever ISO image. It doesn't have to be Linux 8 or whatever you're provisioning your app KVM with. So you would download that and have that ready, or else have the endpoint. And that's in order to have the source installation information. So now we've downloaded that ISO image, and then we will add the source installation information. It could be an HTTPS, it could be an ISO file, and then enter in the VM name. Select the preferred node, which will start up with the app KVM. And then you can specify the OS variant, graphic settings, and there's the disk group here, which is data or RICO disk groups. and then the storage, which we'd created already, which is VM store. In this case, the CPU pool is optional. We did not do a CPU pool. And then we have the number of vCPUs to use, the maximum number and the number to use, as well as the memory size. And then we will have the virtual disk name, and as well as the virtual networks. And then you can specify the VM disk size as well, if you would like, and then create the image, create the instance. So now we've created the instance. We're just going to click through and see what the instance that we created looks like. So we have the VM details here. So if you just click on the VM's name, it'll take you here where it has all the VM details. It has the status. It has what the preferred node is. You can see here the memory is 128 GB. And then you can see there's a 16 vCPU count. So you can see all of the details regarding the app KVM you just created here. So the next thing in this process is to install whichever application you'd like on the app KVM. In this case, it's going to be the Sandbox application for AI Explorer, but you can install whichever else. And then you can navigate back to where we were previously here. If you'd like to manage the lifecycle of the KVM, you can go ahead and start and stop the KVM. If you'd like to delete the KVM, you can do any of those things here as well. You have actions, you can start them, and then once you see this page on the top, you can stop the KVM. So if you want to manage the life cycle at all, you can do that as well over here once you get to this page. So now we're just going to go ahead and start seeing how to install the app KVM. So the first thing is we're establishing a connection and using the IP address that was in that page that's all specified. We'd have the IP address, netmask, gateway, DNS server information. And again, as I had mentioned in the slides, you can use command line and just SSH in. You can also use Tiger VNC viewer. You can use any of these options, or you could use Cockpit, which we will talk about in the next few seconds. But you can use any of these options to connect to the application KVM. So in this case, I'm entering in all of this information, and then I'm connecting to the app KVM. So once you do this, all of this should appear, and then I'm going to the next setting for setting up the Linux OS Linux 8 that I'd set up. So we can see over here, we're just looking at the settings. We're seeing the installation source. You can go through all of these settings, set a root password, see the destination, set up the network, see all of this information and step through it. So in this case, we are going to the installation settings. We are selecting the FTP server. There's FTP server. You can select what kind of base environment you would like, whether that's a minimal installation, whether that's using a server or a workstation or a GUI if you want the graphical interface. So those are a couple of options. So in this case, we have selected those options and we're setting a password for the account. So once you've done this, you're good to start installing the Linux OS. So I'm just starting the installation process. So this will take about 20 to 30 minutes, depending on what the installation software is. So you can wait here and then just wait for it to finish installing. And in the meantime, I am showing a feature called Cockpit, where you just type the name of your app KVM and 9090, and then you come to this UI once you're here. And then you can type the root and then the password as well. And then once you've done this, you will head over here to Cockpit, which is an optional UI feature that you can use. You can go to the overview, and then you can see all of how the ODA is doing, and then you can see how the app KVMs are doing. You can access the terminal. And in this case, even if you have multiple app KVMs, you can see if they're running, you can see what the status is, and then you can also access the VNC console, which is very useful to see, to type in any commands straight into the app KVM. So this is a very useful feature that can be used. You can also use it to manage the life cycle as well. You can use it to shut down or anything else. I'm going to continue here, and then this is an example of like logging in and using this VNC console. So now we're gonna go ahead and show the process of actually setting up Sandbox. And this live lab will be displayed step by step along with a blog and a recorded demo of actually going through the entire process of setting up AI Explorer and this 23AI secure chatbot. So if you're interested in seeing the rest of these steps of how to go through that process, we'll be posting that as well, a recorded demo of that. So this is just an overview of how we're setting it up on the app KVM, and you can set up any app on the app KVM in a similar fashion. So this is just a specific overview of Sandbox. So in this case, I SSH'd in. I'm using this command, as you can see, root C, which is a specific Mac workaround. So just wanted to highlight that in case other users are using Mac and need to SSH and are having trouble with that. And then once I do that, because I'm on an Oracle server, I'm setting a proxy. If you are not on Oracle VPN, you do not need to do that. And then once I do this, I'm using a curl command to install the Ollama library. So I'm just going to go ahead and install with curl on this app KVM. So this process will take a couple of minutes, and it's installing the Linux bundle on this app KVM. And another option, if you want to access this on the UI like we did before, is go to the 9090 port. All right, so once this is done, you can see that the installation is complete and you can run Ollama, and you have it installed in your app KVM. I've also just typed Ollama to see the commands here, such as the serve command or the create or show. So you can display all of these and see these if they're helpful. And then I'm also went ahead and started running this command, system status Ollama. In this case, I was trying to set an environmental variable, but typed it incorrectly. So I did not use it, but just keeping this in the demo just for people who need to maybe set a proxy in their source file. So this is the next step of how you would set the proxy. And then you can go ahead and set it here. I set this incorrectly, so then I just went and did a fresh pull of Ollama 3.2 instead. So I just went SSH'd into this app KVM and then did a fresh pull of Ollama 3.2, and then it just manifests a pull very quickly, and then has pulled all of these scripts successfully. And then once you do this, you can finish the rest of the steps and launch this instance on Podman. So once you've done that, you can start this and launch the instance within Podman. And then once you've completed that, you will see, you can, in this case, navigate to the UI. And that's just going to be the name of your app KVM with the port 8501. So I'm just showing for this specific app what I created on the app KVM, which is a Sandbox app, which allows you to use this AI Explorer chatbot you can upload these files, and there's a bigger demo that's more step-by-step. It allows, once you've uploaded the files, it vectorizes all of this PDF into vector queries with embeddings into your 23AI database. In this case, the ODA that I have has a 23AI database. So you create a connection, and all of those vectorized queries are automatically populated into that database. And then you can go ahead and go to the database connection here, which is how you create the connection. You just state your 23AI database in the connection string. And then here is the actual database, 23AI database, for a bit of behind the scenes of what it looks like. It has the metadata, and all of these embeddings are used for the similarity search for the AI chatbot. So you can see it has the location of all of these settings, and it uses similarity search to find the closest vector to that. And that is kind of the behind the scenes of how, when you search for something in the chat, how it finds the most relevant response based on the relevancy score. And then over here is like how we're actually using the chatbot. So I start with the default settings of the chatbot without RAG enabled. So it is not accessing any of the queries that we uploaded. It's just using, in this case, the Llama 3.1 model, which is a good text model. And 3.2 is a good multimodal. So in this case, I've chosen 3.1. So I just went ahead and asked an ODA, very ODA specific question, which is what is EHA? And this is just generally to the Llama model, it can be to any other model. And the results are not very good. It does not know what EHA is. It's not using RAG yet. So this is what, if you just typed into any, like to Gemini or any other model without context, you would get a response that is inaccurate or is not as relevant to you. And then once we go ahead and enable RAG, it's actually going through the queries and using RAG to analyze the data. And we ask, what is EHA in a similar way? And using RAG, it is able to give an answer which so much more context, and it's able to use the data from the queries to actually find the closest answer and use these sources as well. Oh, sorry, let me click play on that. So once you can see over here, we ask what is EHA, and then you can see that it actually knows what EHA is. It's the Enterprise Edition High Availability Licensing, and then it has the references over here, which you can see, and it's referencing the user documentation guide that I'd uploaded previously. So this is a very powerful tool that you can get very context-based responses. So this is an example of an app that is running an app KVM. There are so many other possibilities of other applications that could be run, and this is an example of one of them. So here are some additional resources for the app KVM process. Here are all of the frequently asked questions that are on the Docs Oracle page. So highly recommend navigating over here and just seeing all the responses on the app KVM. And then also there is a link to the support note of how to create an app KVM using the Oracle Linux template like we talked about today. So here's the relevant support note for that. So would also recommend to check that out as well. Thank you for watching this presentation, and I think now we're going to get to the Q&A.
All right, thank you, Shruti. If there are any questions out there, what you can do is just raise your hand in the Zoom Q&A, or sorry, in the toolbar of Zoom, and we can answer your question live. I think everything's been covered in Q&A. Are there any questions there we want to go over for the live audience? Nothing. Okay.
You know, yeah. Paul, maybe you want to chat a little bit, right? So, um, there was a question where they were asking, is like, wait a second, how do you fill over the application, right?
Yeah, so that's
It's not.
really so the unique feature for the database appliance, right? Because especially on the HA model, it's a share everything architecture. So all the databases, all the application VMs are sitting on the shared storage. So it's just the nature of the architecture that's accessible by both nodes, both servers. So in case one fails, the other one takes over and just restarts the instance because it's talking to the same VM. Again, the VM is sitting on the ACFS, the ASM cluster file system. So it's just the built-in infrastructure. It lends itself very nicely for such a failover. And in fact, that's how we can do, rack one, and the EEHA that Shruti just demonstrated for the single instance database, but so that the same infrastructure also supports the application VM. So again, it's just a very nice high availability architecture for the HA system, and most of our customers use that.